Section 2.6 is on exponents in the order of operation. So we're going to start with a review on exponents. So I start with 2 to the 4th. I know that 2 to the 4th means 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the result is 16. In 5 to the 3rd, that means 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. In the first example, the 2 is called the base, and the 4, and 2 to the 4th, is called the exponent. In example 2, I want to find the value of each expression. 3 to the 4th is the first one, so 3 to the 4th is 3 times 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, times 3 is 81, so our result is 81. Negative 2 to the 5th, that'll be negative 2 times negative 2 times negative 2 times negative 2 times negative 2. 5 negatives, so the result is negative. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. In part C, negative 5 squared. So I'll have negative 5 times negative 5. So we're going to have 2 negatives, so the result is going to be positive. And 5 times 5 is 25. In part D, we have a negative, then we have the 5 squared. So this would look like negative 5 times 5. There's only one negative here, so the result is negative, and 5 times 5 is 25. Now, the only difference between part C and part D is whether or not there were parentheses, so it's very important to pay attention to whether or not you mean for there to be parentheses when you type something into your calculator to use an exponent. So for example, if you wanted to square negative 5, you would need to type the negative 5 in parentheses. Then square it. Because if you didn't use parentheses, you're going to be doing it like part D, negative, then the 5 squared. So we need to be very careful what we mean when we type it into the calculator. The calculator doesn't know which one you are intending to type, and if you are supposed to have parentheses but don't type them, you will get something that might not have the right sign. Okay. Let's look at the order of operations. What is the order of operations? Well, we start with parentheses or grouping symbols first. Second comes exponents. Third comes multiplication, division. And last comes addition, subtraction. Now, multiplication and division will change order depending on whichever one comes first in the problem. So for both of these, multiplication, division, and addition, subtraction, we're going to read from left to right. Okay, so let's find the value of each expression using order of operations. We've got a multiplication, an addition, and an exponent, so we'll do the exponent first. So we have 3 times 15 plus the result of the exponential expression, 10 squared, 10 times 10 is 100. Now the multiplication, 3 times 15 is 45, plus 100. And finally the addition, so 145. In part B, we have a division, a subtraction, and a multiplication. The division is on the left, so we're going to do that one first. 20 divided by 5 is 4, minus 3 times 2. Subtraction, multiplication, we'll do our subtraction next. So that's 4 minus 6. And finally the subtraction will give us 4 minus 6 is negative 2. Okay. Part C, we've got a set of parentheses right here. Note that there's only one set of parentheses. This set right here is just separating the negative symbol from the division symbol. It's not a grouping or parentheses set of symbols. This set is because there's something to do, the subtraction there inside of them. So we'll do that first. So I've got 3 cubed minus 2 times 3 minus 5 is negative 2 squared divided by negative 4. Now I've got two exponents. We'll start on the left. 3 cubed. 3 times 3 times 3 is 27. And then we've got minus 2 times negative 2 squared divided by negative 4. All right, next we have the second exponent. This is negative 2 squared. So we'll start with 27 minus 2 times negative 2 squared, negative and negative, two negatives, so we make that positive 4. I'm going to write that positive in there just as a reminder that with two of the same thing, two negatives will become that positive. And we have divided by negative 4. Okay. Subtraction, multiplication, division. The multiplication is going to come first this time. It's on the left. So we'll have 27 minus 2 times 4 is 8, divided by negative 4. And subtraction, division, our division is going to be next. So this will be 27. Now notice what I'm actually dividing here is going to be negative 8 divided by negative 4. Two negatives will make a positive. So it's not going to be a subtraction problem anymore. It's going to be an addition problem from the two negatives turning into a positive 2. So my result is 27 plus 2 is 29. Part D. Alright, so we've got no real parentheses to deal with, so we're going to deal with our exponent first. So 4 minus negative 2 cubed. This time there are 3 negatives. 3 negatives will be negative. 2 times 2 is 4 times 2 is 8. And its denominator, we have 2 plus 4 squared. So our next step will take care of that second exponent. So that's 4 minus negative 8 over 2 plus 4 squared is 16. Alright, now we're going to take care of the addition and subtractions. So we have subtraction. We know that two negatives are going to make a positive, so let's just go ahead and rewrite that as 4 plus 8 over 2 plus 16. 4 plus 8 is 12 over 2 plus 16 is 18. That division is going to simplify. I can't divide 18 into 12, but I can simplify that fraction by dividing them both by 6. So my result is going to be 2/3. Alright, the next page. We want to evaluate or find the value of each of these expressions. So this one just continues from the last example. So I've got exponents. We'll do those first. So 8 times 8, 8 squared is 64, minus 16 divided by 2 squared times 4, minus 3. I've got another exponent to do. So this is 64 minus 16 divided by 2 squared is 4, times 4, minus 3. Now we want to be careful here that we get the right operation next. We have subtraction, division, multiplication, and subtraction. Since the division comes before the multiplication, that must be done next. So we have 64 minus 16 divided by 4 is 4, times 4, minus 3. Or 64 minus 16, minus 3. 64 minus 16 is 48, minus 3 will give us 45. Part F. We're going to start with the first multiplication, two negatives making a positive 44, plus 2 times negative 7, divided by 7 minus negative 3. Then we're going to do our second multiplication. So we're going to have 44. 2 times negative 7 is negative 14. So we're not going to have addition anymore. Since the number is a negative number, it'll be minus 14. Positive and a negative make a negative. And then divided by, let's go ahead and change that to a plus in the bottom. 7 plus 3. So in the top, 14 minus 4 is 30. On the bottom, 7 plus 3 is 10. This one divides evenly out to give us 3. In example 4, we're going to plug in the values for A, B, C, and D, then evaluate the expression. So the value for A is -3, minus the value for B is 5, over the value for C is 4, minus the value for D is -6. When you plug in a negative number, you need to plug it in inside parentheses. So the top gives us -3 minus 5 is -8, and the bottom gives us 4 plus 6 is 10. Two negatives, turn that into an addition. So I have -8 over 10, which will reduce to the fraction -4/5. In part B, B is -3, so whenever you plug in a negative number, plug it in inside parentheses. You want to square all of B, so you want to square all of -3, minus 4 times A, which is -2, times C, which is 5. So we'll do our parentheses first, our exponent first. So our exponent is -3 squared. There are two negatives because the negative is inside parentheses, so we're going to get +9. -4 times -2 is positive, so our subtraction is going to turn into an addition, +8 times 5. So we've got 9 plus 8 times 5 is 40, so we end up with 49. Alright, the last one, example 5. The number of product introductions with low sugar claims was 340 in 2001 and had increased by approximately 2,003 products per year since then. Complete the following table to help find an expression that stands for the number of products at T years since 2000. Show the arithmetic to help find a pattern. Alright. So in 2001, it was 340. The year 2001 has been 0 years since 2001. Does that make sense? So there were 340. Each year, it's going to increase by 203. So in the next year, we'll have 340 plus 203, or 543. All right, in the second year, we're going to increase by another 203. So we have our 340. Now, in the first year, we increased by a 203. In the second year, we're going to increase by another 203. So we're going to increase by that 203 2 times. So twice 203. If you simplify and add that up, you will get 746. In the third year, you would have had 340 plus, you would have added that 203 3 times. The result would be 949. In the fourth year, you would have taken that 340 and added 4 of the 203, and the result would have been 1152. So what happens in the teeth year? The only thing that changes as the years change is the coefficient, the number of 203s we have. We had 1 203, 2 203s, 3 203s, and 4 203s. That's the part of this formula that's changing. So in the teeth year, we're going to have 340 plus t times 203. So that's going to be the expression for what happens in the teeth year. Evaluate your result for t equals 9. So for t equals 9, the 9th year, we're going to take 340 plus t equals 9. So we're going to plug 9 in for t and multiply by 203. 340 plus 9 times 203. That will give us 2,167. Now we need to discuss what the result means in this situation. Alright, so the result means that T is 9, so it's 9 years since 2001. So that's going to be in the year 2010, 9 years since 2001. And T equals 9 gives us the result 2,167. So that means that there were 2,167 product introductions with low sugar claims.